Hi, my dear students. I am Dr. T. Muthumanikam from Department of EC, Vinaya Missions Kiripanandar Engineering College. Today we are going to see a subject in signals and system. So in that, what is signal, the classifications, that and all we are going to discuss today. Okay. So signals are variables that carry information. It may be anything. Okay, it may be an electric signal or electronic signal or a voltage signal or a current signal, whatever it may be that. And then it is described as a function of one or more independent variables. Basically, it is a physical quantity. It varies with some independent or dependent variables. Sometimes a signal may be a dependent or sometimes it may be independent. So signals can be classified as one-dimensional signal and multi-dimensional signal. Okay, a signal is nothing but a function of one or more variables that convey information on the nature of a physical phenomenon. So which means that it may have one information or two or more information. Okay, for an example, you just see that V of t, I of t, and X of t. So which is nothing but a voltage of t, and then current, that I is nothing but a current of t, and X of t is nothing but an input. So which is dependent on the time. So it is a single variable system. So for an example is a heartbeat, blood pressure, and temperature and vibration. So in that, based on our heartbeat level, right, we are going to measure the our heartbeat, and then similarly the pressure level also, because here everything is a one-dimensional signal. Okay, that's what a one-dimensional signal is nothing but a function depends on a single variable, which is called as a speech signal. Here we are going to have only one signal, that is in a speech. Now I am giving a lecture. Okay, that we can take, we just consider it as a speech. So it has only one signal. And similarly, if it is a multi-dimensional signal, means right, a function depends on two or more variables. A best example is an image. A image has a three coordinates x, y, and z. So we have more than two variables. So that is called as image. Usually we'll say image is nothing but a JPEG. Okay, that is nothing but a joint picture experts group, like that we will say that. Okay. So in classification of signals, we have something, and then one is the continuous time and discrete time signals, periodic and non-periodic signals, causal and non-causal signals, deterministic and random signal, even and odd signal. We'll see one by one. What is a time signal and discrete time signal? A continuous signals take on a real or a complex values as a function of an independent variable that ranges over the real number numbers and are denoted as x of t. You just look at the first diagram. Okay, a signal is varies with the time. Okay, with the continuously it varies with the time. Okay, you just look at the second one. Okay, it is nothing but it is a discrete signal taken a real or a complex value as a function of an independent variables that ranges over the integers and are denoted as x of n. Which is nothing but it is divided into equal number of intervals, and each interval is represented by an integer. So that is nothing but a discrete. Okay, the first one is a continuous. You just look at it. The first diagram, it has a continuously the signal is varying, but in the second one discretely it has variable. For to identify what is a signal and then what is a system, you have to note the in a continuous time and continuous dt signal. Okay, we have a parenthesis and then square brackets. Okay, to find whether it is a ct or a dt signal. Okay, what is a periodic and a non-periodic signal? Okay, as you all know that a periodic means a continuously varies with the time. Okay, that is nothing but a periodic signal. For that, it has to satisfy the condition x of t plus small capital T, which is equal to x of t for all t. Okay, that is nothing but a periodic signal. If any signal is satisfied with the condition, okay, which is x of t plus t is equal to x of t, then we can say it is a periodic signal, which means that continuously varies with the time. Okay, the smallest value of t that satisfies the definition is called as a period. Shown below are the second diagram is nothing but it is a uh, non-periodic signal. So which means that okay, periodic means right, actually continuously. Okay, we have a positive and then a positive half cycle and then negative half cycle. That is called as a continuously it varies with. But in a discrete means right, similarly it is divided into equal number of signal. So similarly in a non-periodic means right, it has only a certain period only it will operate it. or otherwise it will be getting stopped, which is nothing but a non-periodic signal. So what should be the condition? X of t plus t, which is not equal to x of t, then we can say it is a non-periodic. If it is a periodic, x of t plus t is equal to means it's a period. What is causal and non-causal system? Okay, a causal system is nothing but a system which depends on a present input and a past input. Okay, that's what here they have given a function which called t is less than 0. Okay, if it is a non-causal system, means a signal which depends on present, past as well as the future. Okay, so which is called as a non-causal system. Usually say that we have a left hand side, so if we have a left hand side, everything is that we can say it is a causal, which because it has a present and past. If it is a right hand side, means right, we have a future. So whenever we have a future, if you are giving a signal, for an example, if you give some inputs to the signal, if it varies with the past value or a future value as well as the present value, then we can say it is a non-causal. What is mean the deterministic and random signal? A deterministic signal is nothing but a periodic signal, okay, which we can predict with respect to the time. So there is no uncertainty with respect to its value at any time. So you just look at the diagram. Okay, it varies continuously with time. See, we know that okay, this will be the input and this will be the output. So if you are giving the input value some 3, okay, we can say that we can expecting the output may be 5 or 6 for an example. So then we can say it is a deterministic signal. Okay, so what is a deterministic signal means? You just look at the diagram. See, behavior of the signal is random, which means that it is a non-predictable with respect to the time. So even if we just are assigning that okay, that event has to be occurred in particular time. It may occur in a 10 millisecond, but that predicted answer it won't come. So then we can say it is a random signal or a uncertainty signal. So there is an uncertainty with respect to its value at any time. These signals cannot be expressed mathematically. So for an example is thermal noise. Okay, in environmental we have a thermal noise due to the sunlight. Okay, that we have a and then even and odd signal. Okay, even signal and odd signal, right? Okay, if we say that even signal x of minus t is equal to x of t, if a condition satisfied that, then is a even signal. So even is nothing but right, it varies with 0, 2, 4, 6, 8 and like that. See, if it is odd variables means right, it is odd signal means 1, 3, 5, 7, 9 like that. Okay, so with respect to the two-sided spectrum, we have in even signal x of minus t is equal to x of t and x of minus n equal to x of n. Similarly, in odd signal, you just look at the polarities. In the first one, x of even signal, x of minus t is equal to x of t. But here in odd signal, x of minus t is equal to minus x of t. So the polarity is getting changed. So which is nothing but it is an odd signal. Similarly, for x of minus n is equal to minus n to x of n. Okay, what should be the difference between a small t and then a small n? Usually, a small t and small n is nothing but it is a variables with respect to the time. Okay, so that is nothing but a even and odd. Okay, so the odd signal we can say that x of t is equal to xe of t plus x of t, and then x of minus t is equal to xe of t minus xo of t. Okay, so that we can say it is a even signal. And thank you, my dear students.